My screen is visible to all of you, right?
Yes, sir.
Okay.
Yes, sir.
So this is the first session for week 8, I think, no? Yes. Yes. Week 7 we have discussed. Till continuity we have discussed. We continue with the in the in whatever in the week 8 we have. So in week 8 limits are limit and continuity is again is there, just repeating. Continuity we have seen, we'll again see today also. And then differentiability. So please first raise your hand so that whatever you have doubt, I know, so that I know that what is doubt, like in the previous week or anywhere, from anywhere. If you have doubt, please let me know. Okay. And then L'Hopital rule is there. And tangents. Now in the week 8 we have tangent, linear approximation, these two things. In the week 8 also. In the next week, critical points, maxima, minima, and integration. Some part of integration is there.
Integration is basic or tough integration?
Basic integration, not tough.
Okay. So go with the week 8 summary first.
Okay, so yeah. So let's continue with, we have, it is a continuing, like from 2-3 sessions I am taking. So we have seen sequences. And then after limit of function.
Sir, I have doubt in graded assignment 7, question number 5.
Okay. And we have bit seen about the continuity also. Week 7.
Question number 7 also.
Of week 7 graded. Is the due date is over of week 7? Okay. Due date is on 15th. This one, question number 7. This problem, find
Yes,
the
sir.
value of this
Yes,
one.
sir. 5 also. 5 number question also.
Use the given information to find the, this is, we used, this is like, it is kept in some expression, like this is here e to the power, not e, it is multiplied e. E is in the multiplication, so e and nth root of factorial n, and then log with e, and this is in the form of here. Some information is given, a standard limit is here is given, like n, and this information you have, this information, if you have this information, you have to somehow change in this format, like whatever this standard limit is given of the sequence, use that and we'll try to convert in these things so that we will reach to a final thing. What is going to be
Okay,
the
sir.
limit here?
I do it, sir. So please tell question number 7 and 10.
Okay, so yeah, this will continue with the question so that we'll know about the limit also, and it will be so let's take first 10th problem with the containing. It is a part of the sequence, so it will be we'll discuss also that it is just a revision kind of thing. We will quickly see that. Just okay. We have an suppose the company modified the error in estimated by this algorithm Cn. What will be the new error in the estimated algorithm? Error is what? Error in this error in estimate depend on the available number and as so error in the estimated Cn whatever it is given. So here is error estimated by algorithm C prime. This is we have. What is the new error estimation of the algorithm? Means we have to find, that's all we have to find the limit of this sequence. So we have n e to the power 1 upon 8 n minus n. So this is the sequence we have, which is C prime, and we want to find the limit of this sequence. So how we will get this limit? What is going to be the limit of this sequence? We can take n as a common, right? So it will become e 1 upon 8n minus 1, right? Okay, this will become this one. Now this we can write a different notice, like it is look like it will be very like it will go to infinite, but it will not, because of this one it is in the multiplication is here, and minus 1 is there. Because of this one, so 1 minute, it is of what is the error means here? It is of the limit. Error estimation is given by this. Okay, so again, what will be the new error in estimation by algorithm 3? Up to something is missing here. Okay, let's see that what will happen. I don't know. So we can write like this also. This could be written as this, like this, right? Like this we can write.
Yes, sir.
Now this is, we have the sequence now. Let's, because we have, this is 1 upon 8 n, no? So let's make like this so that it will be easier to, like, it will be like this, e power x minus 1 upon x, sorry, e power x upon x kind of thing it will become, right? It will be look like this, or even it will be like if you assume x is equal to, or even m equal to 1 upon 8 n, then it will be look like e power m upon e power m minus 1 upon m, right? Or even if you are assuming x, then it will look like x upon x. And in this case, so if you assume this is, let's assume x is equal to 1 upon 8 n. So as n goes to infinity, x will, where it will go? What is going to be as x goes to infinity? X will go to
0.
it will go to 0, right?
0. Yes, sir.
So we will make like this. So here is, we can make here 8 into, will in denominator we will multiply and like this, so that it will become like this, right? It is 8x, and this is the kind of thing. So we can convert this as 1 upon 8 like this. Now if we are assuming this 8n goes to n goes to infinity, x goes to 0, then where it will go? So in denominator, see that it is going to 0, right? This will also, where it will go?
0.
Now we are done the limit thing also, na? So in the sense of limit, we can think, just assume that, because as I'm assuming x is equal to 1 by 8n, in the limit form also, we can think the same way. So it will go to 0 as this e power 0 will, it will convert, this one will converge where? This limit will go to e power 0, and it is
0.
equal to 1. So finally,
Yeah.
1 minus 1 will go to 0. So it is a kind of what?
0 by 0 form.
0 by 0 form.
0 form.
Okay. And if we, this is one property. So either we can use, this one with this one. So this is the mixing of, I said, right, if you remember how the limit of how will, if we are unable to get the limit of the sequence, so then we can think it as a function, and it will behave similarly as the function will behave, right? We have, if you attended that, or you, who is here, we have discussed in the session that if you are unable to get the limit of a sequence, you can convert the sequence in the function, in the form of function, and find the limit as x goes to 0 form. So, or in the whatever year is happening, after converting that, whatever what we are getting as n goes to, like we assume that x is equal to 1 upon 8n. So we want to find the limit of, we want to find here as n goes to infinite. So that means, and that means we have to find the limit as n goes to infinity. We have converted this one in the sense of that as n goes to infinity, we got that as x goes to 0, and we are now on here, this one, e power x minus 1 upon x. And where it limit goes, you can use L'Hopital rule on to prove it, right? How we'll use this L'Hopital rule? How we got this limit? So this will go to 1. This will go to 1. So for the sequence type, even if you are confused with the x, so we can, let's make it with the same e power 1 upon 8n minus 1 upon 8n in this form. This is the sequence we have. And now see, this is a real number, no? So as we know, in this way you can think, or as in the function form, if you think, so this will go to where, if you think as here e power x minus 1 and upon x, so in the same function form, if you think, it will go to same limit as here, as x goes to 0, this limit goes to 1, and here is the same thing is happening after converting 1 upon 8n as a function kind of thing, x, right? So where it will go? It will go to limit 1 the whole, this in the bracket form. All of you are getting or not? Please stop me if you are not getting. Am I audible?
Yes, sir. So
Yes,
actually,
sir.
for the sequence, you already said that the sequence is also a function
Yes, sequence is also
where
function.
the limit tends to, yeah,
Yes.
where the limit the value of n tends to infinity. So, like here, e to the power x minus 1 by x will go to 1 only when the limit the value of x tends to 0.
Yes. 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 This
So,
is the information we have, no?
so like,
This is the information. As e power x minus 1 goes to, or this whole thing will go to 1 when x goes to, like when x goes to 0, then whole thing will go to 1. Without that, it cannot.
yeah.
So as you are saying that,
So,
sequence is nothing but a function. So this is one correspondence, no? Like sequence is, if we are saying an is a from natural number to real number. See, this is a sequence. So domain of this is a domain of sequence is natural number to real number. And this natural number is a subset of real number, no? So whatever the behavior of the will happen with the natural number, it will very similar we have on real number also, right? This will happen or not, because natural number
Okay.
is a subset of that. So whatever the we
Yeah.
have here will happen with the natural, with the numbers, counting numbers. It will be very similar. Only what is the addition in this real number? It is added. Like suppose here is 0, 1, 2. In the discrete form, your natural number, if you represent natural number, how you will represent? You will represent like this: 0, this is 1, this is 2, this is 3. These are the gaps you have. But if you fill that gaps, it will become a real number. And what you are filling? Rational and irrational number. That's all, right? In these gaps, you are filling the same thing, and
Yes,
it
sir.
will become real number. Now it will become real number. Otherwise, you can think it as a natural number. So whatever we have here will happen on the real number. It will be same behavior will happen with the natural number also. So this is a merging of real number and natural number. What is the difference? Only the gaps I am filling. So that's why whatever the behavior here will happen for the x, and also I'm not changing here is it's look like I am changing x as 1 upon 8n. It's look like
Sir,
a real number,
Shivam,
but it's behaving like a sequence itself. If I am assuming, that's why I said if I assume here 1 by 8n, then it will become e power m minus 1 upon m. And what is the property of this m? As n goes to infinite, m goes to 0. Correct? This is the property. If you are continuing with the, in place of m as, let's talk on the, as uh, on the only the rational form. Now there is no, I'm not including x. It is after including this real number, it will become x. If you are assuming the sense of, if you are continuing with the variable thing x as a real number, but let's change with the m here. Now still the same behavior will happen as, so this limit previously whatever n goes to infinity, this will become m goes to 0. Sorry, it will become now m goes to 0. This is the you have now anyhow, but you have to back on the here on the real number. Without that you cannot, because without that you cannot get this limit, because this goes to 1, the same process. That's why I'm saying the sense of merging, that real number and natural number are merged. Only the gap in between for the natural number, if you feel that
Yes, sir.
gap, it will be the same behavior.
Yes, sir.
So if you, whenever you are looking, so again I am repeating, whenever you are looking a sequence, if you have issue with the on dealing with the sequences, just convert the sequence in the function, and then if you are able to able to deal with the on the function, that's fine. It will behave very similar, or exactly same. Not even the similar, it will exactly the same. Only the differences is you are playing on the discrete number 1, 2, 3 or counting number, and here the real number, and on the function you are playing with the filling this part also, not only on the discrete number. These are the called discrete number, means discretely you are like counting number in the sense of your doing.
So one more thing, sir. Excuse me. So like here, the like which we have changed the like e to the power x minus 1 by x is equal to 1 when limit of x tends to 0. Since x tends to if x tends to infinity, then this standard form is not defined, sir. I'm just asking.
Then in that sense, in that case, it will go to, I don't know. So I have to check that if it is this and x goes to infinite, then it is again a 0, infinite by infinite form, right? So we can use the L'Hopital rule. So it will become e power x. And if you apply the L'Hopital rule, so I will discuss. No? So let me tell the definition. So finally, so this is going to be 1 and it will go to infinite. L'Hopital rule we'll see what is the L'Hopital rule.
Okay.
So yeah, so this limit is not exist.
Okay.
It will go to infinite.
It means it is not defined. Yeah. Okay.
So without merging, it is not clear. Okay, you have to merge anyhow. So with the sequence and function. Okay, so otherwise, if you are able to see here very clearly that this in the sequence form, this will go to 1. and actually this will go to 1. So finally you will got the limit 1 upon 8, this one with the multiplication whatever you have. So 1 upon 8 is nothing but 0.125. So that's why the limit of this one is will be what? 0.125. Just a minute. Okay, is that clear? We
Yes,
also
sir.
discuss on the sequences, no? So is that clear now?
Yes, sir.
Okay.
Yes, sir.
So let's discuss the 7th problem on limit also, then we'll move on to continuity.
Yes, sir.
It is
Question number
actually
7.
revising. We are doing some revision. Okay, whatever we studied, we have seen discuss on the 2 sessions back or 2 session. Okay, so this is okay, just okay. So we have this limit. Find the value of 5 into is there 5. This is floor function, greatest integer function. X goes to, this is X is here. X goes to 9 positive, 5 is in multiplication, then minus 3. It is 3. Minus 3, limit X goes to 3 positive. This is we have X. So what is going to be the limit here? It is on the limit of function. So this is the function we have, fx. And not even function, whatever the function, it is a limit is given. It is a 2 type of function we have. One function is not 2 type, the greatest integer function. My screen is visible, right, to all of you?
Yes, sir.
Okay.
Yes,
So here is the limit of greatest integer function, which is generally called floor function, and limit at 9, and not even the 9, it is a this is 9 plus, means right hand limit or right limit. This is right limit. Here is also 3 plus, means right limit is at 3. Right limit at 9. This one is right limit at 9. This is right limit at 3. So there is a limit when we are discussing the limit. So there is 2 type of limit we have seen, left limit and right limit. So left limit is generally denoted as x goes to at some point A. So here is, if A is here, so left means here from this side means a smaller number. You are increasing up to A from the smaller number, that is called left, and denoted as you are approaching to A from the left, means you are approaching to A with the numbers, real numbers, which are lesser than A. And the right limit is generally from this side, means you are approaching to A with the numbers which are greater than A. So this side. So this is generally denoted as A positive. So here is we are talking about A positive. So and so here it is nothing but approaching to, so if you have a limit as x goes to a fx, it is given. So that means you are, so for a function it is given, so that means here you are approaching to this a from left and right both, where the function is behaving, like what is going to the limit. If it is kind of this one, okay, and we have there is a problem at a. So what we will look very analytically, like here is that this is the analysis thing is now we are doing very, very closely. We are observing that what is happening when we are approaching to a here, what is going to be with the function. It is at like this, our limit is going to be, or at, if you are assuming, suppose this is a function value of a, okay, if you assume that this is f a at a, this is f a. So if you are approaching to a from left, is that approaching to exact fa, or it is a different number? Or the similarly here it is from right, if you are approaching to a, the outputs you are means limit in the sense of you are continuously giving the inputs from this right side, and what is happening on the function output, and we are observing, that is the limit thing. So here is the same, we have the greatest integer function, this one, and we are giving input which is 9 and greater than numbers. That's the limit mean. Here is limit means you are giving the inputs and try to get that what is the final limit. The word with the limit, we have seen that what is going to be the limit thing. Like if you are, there is a issue with 9, no? At 9 it is, there is a problem in the greatest integer function. So let's see that a greatest integer function. The greatest integer function is like this. It's behave like this. This is generally circle means here. What we'll see, I will tell you that here is circle, and here is solid, is circle, and here is solid. So circle means here is I'm making a circle, and here is a solid point. So that means if you are
Solid is included and circle
circle is excluded. Like in the if you are assuming C, here is if it is 1, and if you are here is 0. So if you are, I'm making here solid means we are talking about, if both are solid means we are talking about closed interval. Means I am including that number in the graph. Here is in the graph, here is means if you are some output is there, so I am including. So here is circle is there, some means I am excluding. So if it is, here is suppose circle I am making, and here is some number 2 and it is 3, and here is solid and here is circle. That means I am including 2 and not including 3. That's why it is a circle and this is the solid. This is the difference here is me. So this is a circle. So greatest integer function. So here is a circle now in the greatest integer. So the same way, if it is 2.5, so if greatest integer value is going to be 2, as the name itself, if you read out slowly, greatest integer function, and that number which is integer number and greater than, so greatest integer means largest integer, or in the sense of what is integer which is less than this number, but it will be the greatest. So 2 is the integer in compare of other integer, but less than 2.5. If you read out that name, it is saying the same thing. So it is going to be 2.5 is 2, 2.9 itself will be again 2. Okay. So this is the function you have. Now we are at, suppose here is 9 for the time being. Suppose somewhere it is 9. So it is, so let's make it, something, there is a gap, or even this is assuming to be 9 here. I just assume that here is 9. It's look like 3, but it assume that this is 9. So if it is 9 here, so from the left, if you approach here, if you will give input lesser than 9, see the output is coming here. Okay. And from the right, if I am giving input, so there is a jump and output is coming here. So this is the jump. So, but we are here for the right limit means we are talking about this side, and we are giving input and try to see what is the output is coming. It is coming to be a fixed number here. Okay. So this is the fixed limit. Sorry, fixed number. Around that you are getting the output. So that fixed number is said to be the limit as you are approaching to A from the right means here is as approaching to 9 from the right. So this is going to be what? 9. And it is very similarly again it is 3. So what is going to be again 3 from the right side we are giving means what? The number you are approaching which is greater than 3, 3.01, 3.0001. These are the number which are greater than 3 and very close to 3. So in that case again it will become 3 as the definition that so this right limit is also going to be 3. So this one is going to be 3. Now this is 5 into 9 minus 3 into 3, it will become finally, and this is going to be 45 minus 9, which is some number we'll get. That is 36 roughly you'll get. I don't know what is 39. Is there any error? This is left, no? Here is I made right. So here this is the minus sign is there, and I or here made plus. So so we have seen here for the positive both right limit for the both limit as is given. So let's make it again. This is 5 9 plus minus 3 limit is here limit 3 x approaching to 3 negative means from the left. Greatest integer again the function same meaning we'll do. So this limit will go 9. Where this will go now?
2.
Anyone?
-2.
Why -2?
Sir, it's 2.
Sir,
This
it's
is 2. The
true.
power is there, no? It is means why
It's
minus
true.
2? This means you are
Sir,
approaching to 3 from lesser than number. Which number which are less than 3?
0, sir.
0. Why it is 0? This number only. This I am saying this one. This limit.
2.
It's true.
2.
2.
So it will
True,
go
sir.
2. So 2. So finally 5 into 9 minus 3 into 2, which is 45 minus 6, which is 39. So this is the limit property. Now let's add one thing more, that continuity. So what I'm adding, so suppose see the same behavior it is, okay, same function on the greatest integer function, okay. Let's make a different picture, or let's say now we are deal with the greatest integer. So two different picture I'm making. So suppose a graph of a function is like this, okay, and here is a solid and here is a circle, circle, and here is a solid, okay, and this again like this. Please all of you mute yourself. Okay, and then I'm making a sharp edge, or let's be continue like this. It is there is no issue, and here is I'm just making a dot, okay, like this, or even you can think if it is sharp or dot is whatever. We'll see that what is happening. The two things we have, okay. Suppose here is A and here is P. Now we are looking continuity, okay. So the same greatest integer as we have seen, we are approaching to from the left. It is denoted. It is denoting as a negative. From the left we are doing, and suppose this number is alpha and this number is beta, and here is gamma. Okay, this number is dot point is gamma. So as we are approaching to a this function is fx. Fx approaches to from the left. You can see now as we have just now seen in the greatest integer function. It will approach to alpha. If you do x goes to from positive signs, see that if it is from positive, there is a jump here. Outputs we are getting started. I started getting here, and here is the fixed number. Around that you are giving around this number from the right side, and you are getting around the output around this number. Here is very close to beta. So in that sense, this is right limit. It is called right limit, and in that case, fx goes to beta. Now let's back to here. So here is
Sir, is
again
this
think
a
about.
continuous graph? Can we say that?
So I will tell you. So I will tell you now. Okay, I will tell you that. Okay. So here is
Okay.
beta now. Now again we will same way we will think. Okay, whenever you will think, it is same, right and left. You are doing analysis here now. Okay, if there is a issue, the problem is where. So we will look, if we will see a problem, we will tackle that point. At that point we will attack, or we will see or try to analyze where is the issue. So in the whole graph of a function, if you assume this is the same continuing and this is the same continuing, so the problem at only A and B, at this point there is a problem, and everywhere is a smooth, or there is no smoothly you can draw, or whatever you want to think, it is there is no, these parts are very fine, there is no issue. The problem at A and B, and we are analyzing that. So when you are started analyzing, you will at a particular point, so we'll do the limit thing. So limit thing will analyze with the left and right. Okay, so same way we will think also here, we'll analyze B with the left limit. So this is from the left, that is called left limit. So this whole final thing is called left limit, left hand limit, and this whole final thing is called right hand limit or right limit. So analyze with the left and right limit. So as x goes to beta, so see that from the left side it is actually coming to this gamma. So fx goes to gamma, means we are done with the left hand limit. Okay, now again let's talk about the right hand limit. So let's approach to beta from this side, and again if you see that it is coming with the same number gamma itself. So from positive side, fx also approaching to gamma. Okay, this is called right hand limit. Now two things we are observing, the case of A, and this is a case of B. Okay, okay, now so one thing I'm not missing here, I'm just including that, and this beta, this sorry, this B, input B, and here is the gamma. Okay, this gamma B, or gamma is exactly, because it is defined, no, it is the same, at gamma is nothing but fb, function value at B. Okay, function value at B. I will tell you a different thing also. I need to make here the different, or I need to make it to, let's make a also another place. Okay, I'm just making this gamma, if you are assuming, I'm not adding here, so I'm making like this again. So this here is gamma is nothing but fb. Okay, this sorry, this gamma is nothing but fb. Okay, so what is now here, what I am doing, and the next place here is issue with the C again. As what is the issue here is, again I'm making circle here. Okay, again I'm making circle here. Now that's why it is now clear that what is solid as circle. So solid is here. Okay, now again circle is here, and it is continuing. See the differences. This side circle, this side circle, solid is exactly here. Okay, and now it is now continuing. What is the meaning of this solid I'm making here? What is the meaning here?
This that point should be included. I mean,
No,
I
so
think.
here is included means here what is, this is this part is of the graph.
This is a value f of c.
F of C. This value is f of C, and from the left and right, that point is not going to be. It is going to be some different. So let's say this is again I am giving, or even or even let's say this
So we
is.
are checking, sir, LHL is equal to RHL, right, sir?
Also,
So here
LHL
we are
and
checking, here we are
RHL will be
checking
not
left
defined.
hand limit, right hand limit, and function value. Same way at three places we are doing the same thing. Also we'll see the left continuity, right continuity also. Okay.
Yes, sir.
So in the same figure we are discussing. So this is we have, and okay. So this number, it is the circle is becoming at the same, both side at the same. Let's say this is that whatever the height you are, means here whatever the output is coming, both left and right are actually getting the same height. So this is, let's say, R, or if R is problem, alpha, beta, gamma, delta. I'm making a delta here. This number is whatever the output is coming around delta, left and right. So means here as the circle is here getting, that circle is whatever you are getting, that height is exact is delta. Okay, and here is what? Sorry, here is alpha, here is delta. So here is left limit as x goes to c from the left, function value approaching to delta. As x goes to from positive side, this side, from this side, from previously this side, again delta you got, from right side also you got delta. Okay, fx approaches to delta. But see, the difference is that function value at c is f of c, and it is not same as the graph is, we can see from the graph. This is different, but here is the same. Here is the same. So this is called, this portion B. At portion B, function is continuous. Okay. The case of when
Sir,
the
I
function
think,
value exactly here is nothing but
sir,
f of.
sir, wait.
Yes.
I think there is a sharp corner. So how you can say there is function is defined?
So sharp
At
corner
B.
still there is no issue, no? If it is a sharp corner, there is no issue. The sharp corner create problem for differentiability, not continuity. Okay. We'll in the same picture we'll back to again, okay, and discuss the differentiability also.
Okay, sir. Thank you.
So the sharp corner create problem only for differentiability. Okay. So here is, this case is for if gamma is exactly f of beta, means as here it's look like. So this is, this at this point function is continuous. Okay. And also with the pen, if you take the pen and nip of pen and continue this, for this point there is jump. So means here you have to lift your pen and then back to keep here and then continue. So if you again continue here, okay, there is a sharp corner, but still you are not lifting your pen. It is continuing now. There is a, we know there is a sharp corner, but there is a issue. There is no, we are not lifting the our nip of pen. It is actually continuing. So continues here and back to the next point C. Where is the issue? And again at here, it is here. But for the value getting at C, we have to lift our nip of the pen and then keep here and then again back to here and continue. So while drawing the graph, if it is a pictorial form of the limit, continuity and differentiability, it is in the pictorial form we are looking. So whenever you have to lift your pen and then keep at different place and then continue. So where you are lifting that point, at that point a function is not continuous. We are only talking here for the continuity thing. Okay. So at A and C function is not continuous, but at point B function is continuous. So now it is in pictorial form and also in the algebraic form that we are looking here in this below side here. It is so in the form of that, if you evaluate the limit, left limit, right limit is exactly the same and also equal to the function value. So in that case, function is continuous. Gamma, both limit are left limit, right limit are the gamma, and it is exactly the function value of B, then function is called continuous. And at this point, you can see function is not continuous. Okay.
Left hand limit and the right hand limit equal, then the continuous function, and left hand limit, right hand limit not
No,
equal.
LHN is equal to RHN is equal to f of A.
Yes.
Then it is a continuous.
Now let's talk about the left
Not
continuity
continuous,
also.
discontinuous.
Left continuity and right continuity. Left continuity is and right continuity is nothing but a means a part of continuity. Means here what is that difference is that here is
Left hand side, sir, one left hand side and right hand side equal, then the condition f of A infinity.
then the condition of
Left hand limit and the right hand limit equal, then the continuous.
then the continuous. Not only equal, it should be equal to the function value. Here is, see that it is equal. Here is left limit and right limit are the same, but not equal to the function value.
But this graph equal to this f is equal to b and delta.
Sorry,
It's
I'm not
continuous.
getting.
Actually, sir, beta and gamma,
Hmm.
and this graph is continuous.
Problem at B, problem at A, and problem at C. Function is not continuous.
Oh, delta and gamma.
Delta and
Gamma,
no,
gamma.
not gamma. Gamma is continuous, no? Delta means let's talk about for the corresponding to the point here, B and C and A. Not here. Output is we are getting output with the function value that is, but the inputs with the corresponding input it will give. No, for the output we are getting two different things. So talk about the input thing. Say to at A function is not
Sorry, sir.
continuous. At C function is
Continuous,
not continuous.
continuous and discontinuous function. Can you please
If
one
function is not
word?
continuous, that means the function is discontinuous. That's all.
Yes, yes. Oh, check the function this graph.
Hmm.
Okay. Okay, sir. Okay, week 5
If you are
related.
not getting, okay, my suggestion is you are not getting, so see, that's why I'm keeping effort much time here to spend to see. If you are not getting, I will suggest you please watch again and I'll try to observe what is happening, what are the word I'm saying. So this is a major difference. That see that I forgot to tell you that the left limit and right limit are same, but it is not equal to, not I'm not forgetting, I just made that, but I didn't tell. See that it is left limit and right limit are same but not equal to the function value. So here in this place, at this place, you will say limit exists. At this place limit exists, which is what? As x goes to C, finally will represent like this. X goes to C, f of x goes to delta. But so limit exists but not continuous. And I also told you reason, no? You have to lift the pen, continuing to still see here delta, but at exactly C, you have to lift your pen and keep here, and then for the next head, you have, when you are moving, again you have to lift your pen and keep here and then continue that. So that's why at this place function is not continuous, but yeah, limit exists. As x goes to C, f of x goes to delta. Limit exists, but not continuous. But at gamma here, it is continuing. There is no lifting of the pen. Okay. And it is here, see that left limit, right limit, and function value all are same. So that's why here is continuous
Yes.
and also limit exists. But see it here. At here, from left limit, you are getting different, and right limit, you are getting different. So here is limit not exist. And limit not exist. And also the limit not exist, then in
And
that
it
case,
is
directly you will say function is not continuous. And also with the pictorial form, you can see that there is a lifting. We have to lift our pen, then keep on different place and then continue.
Limit equal than the continuous graph. Yes.
So limit equal to the function value, then you will say not only sir left and right would be the same and exactly equal to the function value, then you will say. So here is the one definition came, the right continuity and left continuity. So here is function is, if you are getting output, here is what is beta. Beta is nothing but, because here is solid, no, means here you are getting a function value at A. This is beta is nothing but f of A. That's why it is solving here. So solid point is here. Okay. Now see that this function is, this beta is nothing but function value at A. So this is what is called, only this bracket is called this. It is what? Right limit exists and equal to the function value. So this is, in that case, it is called right continuous. It is right continuous. But here it is not left continuous. Why it is reason? You are getting limit as x goes to a f of alpha, but f of alpha is not equal to function value, which is beta we have, not the alpha. So this is not left continuous, but right continuous. So this each bracket telling you a definition that it is a left continuous, okay, but not right. Sorry, it is not left continuous. It is not left continuous because alpha is not equal to f of, but right. So what is happening here? There is no need to remember even what is happening here. The same definition is happening here. Is the function value and delta is different, okay, but here is all are same. So whatever the limit you are getting, either the function value is one of the side is happening or different side is happening. In that case, you can tell that it is going to be left or right continuous. As like here in the case of here, this one in the greatest integer function. So can you tell me this greatest integer function is left continuous at, suppose this is 2. Suppose this is 2. Okay. So what is that 2? It is left continuous or right continuous?
Right continuous.
It is right continuous. Anyone getting different answer also or question why it is so?
Sir, how it is right continuous?
So let's find that. So if you are arguing that, so in your word itself, you will answer that. What is the limit at, what is the left limit at 2 or left limit of the function at 2? Can you tell me if it is 2 here in the greatest integer case?
1.
It is going to be 1. And what is the right limit?
9.
2.
No, at 2 I am saying, okay, at 2. So it is, right limit
2.
is 2, sorry, 2. And what is the function value at 2?
2.
2. So now it is true, right? It is right limit is equal to the function value. So it is right continuous.
Okay. Or
All of
we
you are
can also
getting
say this graph is continuous.
which graph? This greatest integer.
Yes, sir.
So
No, this,
except
sir, this no discontinuous, no, because of
this
the
is discontinuous. So one thing here you need to note that, yeah, in this interval 2 to some fixed number, is suppose here is 9 I'm making. I'm now raising that. I'm saying 2 into this is 3. So in this interval it is continuous. See that each part you don't lifting, you are not lifting your pen. It is continuing till here. So it is continuous. In between right and left and the function value all are same. So at this interval at here in this part it is continuous, but there is a problem only at integer point. Okay, so this is the case for continuous also. Almost thing I have discussed for the continuity. I will suggest you that please, if you are not getting, please watch again this one. Many things I have said, and also this picture is saying everything. This graph itself is saying everything.
So
What
go
kind
with
of
the
thing?
derivative.
So now let's move to the derivative thing. Continuity is done now. And also we have seen with the an example on the greatest integer that it is the right continuous or left continuous. Okay, now try yourself some problem, then you will get that.
So one question.
So I'm just making, okay, so for example, I'm making a function, okay, x plus 2 when x is less than 1, x when x is 2 function I'm making greater or equal to 1, and a different function gx which is of this type, okay, x when x is less than 0, x square when x is greater than 0 but less than 1, and x cube, okay, when x is greater than or equal to 1. Okay, two function I have met here, and I hope you can easily draw this graph. All of you are able to draw this graph or not? If you want to try to this graph fx, see the graph. with the graph. First, without drawing the graph, let's talk about their continuity and
This
So
limit
is
thing.
fx is
this
not
is
continuous, I
discontinuous. Huh?
think. Yes, sir,
This
fx is discontinuous.
fx is discontinuous, and this gx is a continuous.
Okay, fx is not continuous, and gx is continuous or not?
Yes, continuous.
It is going to be
Because
okay.
x less than is equal to 0, 0 to 1s, and this is, yeah, continuous is this gx.
It is going to be continuous. So let's see with the no definition without drawing the graph. Okay, this algebraic thing, this limit continuity is actually why it is created in the, you can know, if you are, we are unable to draw each time the graph of any very complex function. So for that we'll do very algebraic way, that is in the calculus form, that is limit continuity. In that process we'll try to analyze that how the function we having. So here is left limit is going to be at 1. So see, the problem is only at 1 here, at 1, and here at which places the problem is there? At 0 and at 1. Here is problem at 2 places. For gx is at 2 places and fx is at only 1 place at 1. So here is, we only talk about the problem point, which is what is going to be the limit, left limit at 1. So what is going to be the left limit here? Anyone?
1, sir, 1.
1 left limit I am saying.
Oh,
No, sir, 2, sir.
2.
2 or different?
Approx 2, sir. Because when we 0.5 and the
There is
2.5.
approx means there is no approx. Limit thing will tell you without the approx, no? Limit is giving some number always, some real number, not approx. So what is going to be the limit here? Left.
So 3.
Yes, it is going to be 3, no? As
How
you are
3?
approaching to 1, you're just giving the number, no? It is saying to be, here is just giving the 1 plus 2, which is 3.
Because, sir, actually equal to -1 selected, no?
Not
So
minus
we
1,
are
here is,
not putting the value of 1. We are
why you
putting
are not,
the
why you will
nearest
not
1.
put the
मतलब
value of 1?
1 से छोटा.
Once is chota, so that means that there is, that's why this limit word, no? If it is, so where it, this part will go, okay, can you tell me where this will go when x goes to from left? What you will give that number when x goes to 1?
1.
1,
At
yes.
least you will give 1, right?
1.
So that's the
Yes.
thing here. Limit and limit you are adding. Here is as 1 goes to, and this one where it will go as x goes to 1.
Yes.
It is constant function, no? So it will still go to 1. Sorry, it still will, sorry, it still will go to 2. It is a constant function. So you can break your problem. If you are not able to guess that, you can break your that function itself. So this is one part. Otherwise, just substitution you can do here. At least you have to substitute here, because there is no issue with the substitution. You can substitute. So that's why this is going to be 2.
Yes,
sorry,
I
3.
got it, sir.
And what is the right limit here?
Right limit is 1.
1.
Right, is limit is 1 as we are looking, right? This is going to be the from left 1. So the same way our approaching to 1. So this will go to 1. So see, the jump is there. So left limit is not equal to right limit. Left limit is not equal to right limit. So limit is not exist. Not exist. Limit. Limit is not exist. So function is not continuous. So if function is not continuous, so now we will talk about the left and right continuity. Okay. If not continuous means, okay, don't worry. So now we'll talk about the left and right continuity. So what is this function is left continuous or not?
Yes, sir, left continuous. No, sir, right continuous, sorry.
Right continuous.
It is
Right
right
continuous.
continuous, not left. Because at 1, what is the function value at 1?
1.
It is
1.
1, because greater or equal to sin SI means equal to 1 only. Function value is 1. but function value is equal to the right limit. So it is right continuous, not left continuous. If it is equal to, suppose I'm saying for the time being, if I made it 3 here, so function value is 3 at 1, function value is 3, and left limit is 3. So it is right continuous, and also it is continuous or not. First thing, is this continuous? Now it will become continuous as the left limit, right limit is also going to be 3 in that case. So let's make it with the same. So this is right continuous. Now let's back to over here. So problem at 0 and 1 only we'll see, because rest all it is smoothly behaving. Like this represent a line, less than 0 it represent a line, between 0 and, please all of you mute yourself. And between 0 and 1 it is a parabola. And so let's draw first. Now let's draw. Now we are analyzed with the calculus part. Let's draw the graph of this fx. So how it is, when x is greater than 1, we have like exactly the identity function. So suppose here is 1, and at 1 we have like suppose here is output is 1. So we have a right side exactly identity function, means like this. But when x is lesser than 1, we having like this. That means x plus 2 means y-intercept. Now it is also a line. Y-intercept is 2. So that means this is 2 here, and right side is like this. Is there any issue with drawing this graph? So here is not here 2. Here is exactly at here you will get, not till here. There is a gap is happening. Till here is you are getting 2. So where it will be circle, well it will be solid for the in the sense of function. Here it will be solid or circle, or here it will be solid or circle. Now if you know the solid and circle thing.
It
Solid
will be solid at 1.
1.
Exactly
Here.
1.
Here.
Yeah.
Because you are attempting 1 here. Here is going to be circle. Without that it is not clear, so you have to anyhow make, because now it is telling the whole picture now that it is in the correct. On here whole real line it is saying that okay, now you are getting at 1 these values, and now except those points there is some, and this is the discontinuity part. So this is right continuous. Now for this one I just draw the graph. It is very clear that it is at 0 1. Now let's draw the graph. It will be easier to show many times. Let's talk about the derivative. We'll quickly move on that. So how it is less than 0, we have like a identity function. So that means like this, and here is not equal to sign, exactly strictly less than. That means you can make like this. Here is circle, and this part is going to be like this. Now between 0 to 1 we have like a parabola. So here is 1. So we have like a parabola. So parabola is going to be how x square. It is like this. So here is 0, here is 1. So it will be like this. At 1 it is assuming to be 1 1. So this is a parabola. So a parabola, it is however it is a curve kind. Suppose here is 1 1.
Axis of symmetry at 3.
So here is 1 1. So this is 1 1. So parabola. Now x cube kind of thing. When x is greater than 3, it is x cube. So here is, so it is continuous. That's why all are going to be solid here, because from left side you are going to be 1. Here is from the left limit is at 0 is 0. Right limit as 0 is also 0. So that's why it is going to be continue. Here is continue, and now x cube is there. So very sharply it is increasing. This is x cube, this is x square, this is x. In these three parts, it is moving like this. This is our function. And it is continuous at everywhere, at 1, 0, all even whole real number. Okay. I hope now try yourself, try to draw the graph, try to draw the stepwise functions also. Okay. Stepwise function means in that interval, your function behaving like that. That's all. In this interval between 0 to 1, the function behave like this. After 1, behave like this. Less than 0, behave like this. This is the mean of stepwise, and that's all about talking about the left and right. The problem is that for the problem which function continuity or differentiability also creates will create problem for stepwise function, or stepwise function have issue with the such thing that continuity left, right, or differentiability.
Sir, in this case, does limit exist or not? G of x.
Without limit existence, how you will say the continuity?
Oh, okay.
If it is limit is not exist, then how it could be continuous? And a function is continuous means limit is surely exist.
Okay.
See the definition of the continuous. If you see the definition of continuous, it is built based on the limit. It is not directly set. It is built on the limit.
Got it, sir.
Okay. So let's move on to differentiability. So we'll see the differentiability first in the pictorial form. Okay. And then in the below of it, I will write the differentiability definition also. So many cases here will be. So okay, so first thing is already will come here. This part will come. These all will come in the case of here. So I will quickly making it here. So here is, let's say, it's like this, and then like this. There is, a kind of asymptote is there. Or not even asymptote, it is not asymptote, it is in that form. Asymptote is already itself says the function is not defined there. Okay, let me make a yes shape. Yes, kind of shape. Let's say I'm making like this. And then this two are that there is a break, there is sharp corner, and there is a jump. If a jump is done, jump, sharp corner, or again that part is coming. If you continuity part is there, jump, sharp corner, and this part I can include. And this part is already 1. 3 is done. Okay. So without that, I'm making here is a circle, and here is a jump. And then again continue. So 3 points I'm now including here. This is, let's say this is A. There is a problem at B. There is another case I made it here. Okay, here is C, and here is D. Okay, so here is, we have previously seen that this at this point at A, not continuous. Now I'm just writing not continuous. Okay, we have previously seen that it is continuous. What about this? Is this continuous or not?
Continuous.
It is continuous. No, we are not lifting the pen. It is actually continuous. So it is continuous. And not continuous. This one we have seen. Okay. So not continuous. Now let me write the definition first of all, the differentiability definition. That suppose I am taking a function f. I'm like this. I'm defining. So writing like the function is distance that domain is R, codomain, or even this is called. So this is codomain. This is domain. So function we have, and A belongs to that domain. This part. Okay. And there is a issue. So A is not, here is I'm just making C and D. So B and C belongs to, or even A, B, C, D all belongs to this domain. Okay. And okay, so I'm just writing a without this A, B, C. Okay, I'm writing a definition saying to be at let's say theta. Okay, so I'm writing to be theta. I'm saying at theta is a real number. Okay, theta is any real number. Don't worry, just notation is like this I'm making because of so many variable I'm using. So theta is any real number. Okay, that's the meaning here from the domain. So differentiability at theta of a function f is this one. There is no different definition. Okay, there is no different definition. The limit definition here for the differentiability. Anybody is asking the what is the definition of differentiability, so we will say like this. Suppose a function is from R to R and there is a real number theta, and theta we are saying to be a function is differentiable, means this is the definition. H goes to 0. Okay, theta plus a small increment, and this increment is either could be positive or negative, means either could be greater than theta or less than theta. Okay, and exact value at theta and divided by h. So what is the meaning here? This tells you, this tells, let's see the first, we'll back to here. This all will back to here. We'll back to this part, but before that let's analyze this one first. Okay, and this is we have. So this is if this exists, this limit, see that there is nothing more. It is exactly on the limit definition. If this limit exists, then you will say function is differentiable at theta. That's all. That's all the definition of differentiability at some particular point. If this limit exists. So see that the definition of differentiability, definition of differentiability is nothing but the depend on the limit itself. If this limit exists, then you will say. Now I'm asking from your side, when we will say limit will exist or not at some particular point.
LHL should be
When
equal to
LHL is equal to RHL, then we say the
left
limit
hand
exists.
limit should equal to right hand
Then
limit. Left hand limit should equal to right hand limit. Okay, that means here we have to think about the left hand limit and right hand limit surely, right? Then we will talk about. So I am just writing now the new thing, that in the not new thing, the same thing, but in the case of left hand limit. So it is just a notation. Please observe. I am just in the notation form. So see h is approaching to 0 means what? If here is 0, okay. So I am approaching to 0 means I am from left and right, both side I am approaching. So now I am saying the left hand limit for this limit. Okay, so I am writing h goes to from left. This is the notation I am continuously using. Okay, now f of theta plus h, f of theta upon h. Same thing I just wrote from this left, and this is right. Okay, now I am changing. Okay, what I am changing? Please observe this change. Okay, I am changing this y. See, I will tell you the whole notation, what is happening within the lecture, and whatever is generally uses, you will not now, after looking this one, you will not fear with this notation thing at least. So this I am changing h is equal to minus h. Sorry, y equal to minus h I am writing. What it mean that? What is meaning is saying, now in the sense of here, as h approaching to 0 negative from, it means this side. Y approaches to what? Y will approach to where? Please see this equation, this one. And now can you tell me Y will approach to in the notation form 0? What you will say? Anyone? Anyone?
Y approach to 0, sir.
Y approach to 0, sure. But it will approach to 0 from left or right? I'm just making here now for, this is for H. Now I'm saying for Y, right? Here is 0. This line is for Y. So if H approach to this side 0, I'm sure that Y will also approach to 0, but it will be from left or right?
Le-
Left or right? So here see the
Left.
sign and then tell.
Yeah, left side, sir.
Why left? Here is I made negative, no, here. Minus H.
Oh, left limit, yes. Left limit negative.
So where it will now, right will approach to from which side?
Right.
It will become negative, negative will become positive, no? As H is, these numbers are negative number. I am making here negative again. It will become positive, means Y approach to from this side. See the differences here. Is this clear? Is this clear after changing this one like this? So many notations using, don't worry, X, Y, Z, all are real number. Okay, X, Y, Z, alpha, beta, gamma, delta, all are real number. Only just saying,
This I have not understood, sir.
just a variable thing. Okay. So is this clear? Y is approaching to 0 positive.
So no,
So,
sir.
No?
So it is not clear. Can you please explain it again?
Okay. First thing, are you observing this one? All of you please observe this. This Y equal to minus H. Okay.
Where this Y comes from, sir? I don't know. Like
why I'm saying, just assume.
Okay.
I'm assuming. Just assume that Y is equal to minus H.
Okay.
Okay. Now, you know H is negative because I'm saying H is approaching to this. This tells you that your H is negative here. Negative number, less than 0.
Yeah. Yes, sir.
Now, H is negative. I'm making here minus H. So what it will come? Whole thing will become? What will become? Here is minus ahead and H is already negative.
It will become positive.
It will become positive. So now
Yes.
let's see in the notation form, H is approaching to 0 from negative. So Y approach to also 0.
Okay.
But
Got
it
it.
will be from positive in the notation form.
It will be RH. Okay. Yes, sir.
Why should we
This-
take it like this, sir?
So I am taking because of I want to change here minus. Why? So if you see the definition, so many notations. If you see in the activity, why I'm saying I want to show you the also. So now it is clear, no? So let me show you the on the pictorial form that why I'm using this one. Why so many notations I'm using. So actually, what I am doing here is theta. Suppose here is theta, and here is the graph of a function. Okay. So here is f of theta. Okay. Here is f of theta. But this, what is this? This is an increment, no? Okay, so what is that? What is it? Okay. So this is f of theta. I am saying this h is from negative means. So what is happening with this sense? F theta plus h. What it is, increment or decrement? Can you tell me?
Increment.
Increment or decrement?
Theta plus h is increment.
No, decrement will, no, because from you are approaching from negative means your h is negative, means from this side you are approaching, your h is actually this distance, means here is your theta plus h. That's why I'm using notation. So that's why I'm saying this is minus h, and now it will be change a kind of limit y goes to 0 positive f of theta minus y. So many notations are there. I will repeat again. Okay, this is y. Okay, so it is now mixing. This is correct one, but it will, you will all of you will get the very, okay. So okay, these parts are actually happening. Okay, if you okay, for the time being, just forget about. So this is, I am saying now in this sense. Okay, H is always be. Oh, so let's continue with this, whatever we have. So here, this is the decrement is happening with in this sense, but here is theta plus is written. No? So if you are saying, if I will make it plus, then you will say this side it should be, but here is H is negative happening. No, so let's make it here theta plus itself also, but here is, you will see that here is a decrement is there. So this is going to be here somewhere, f of theta plus H. And what is the limit thing of what I am taking here? This difference is upon this difference, and see that what is this fraction, whole fraction is there. This fraction is output difference upon input difference, means theta plus H minus theta, which is exactly H. And I am taking limit, H goes to 0, means I am reducing this difference very close to theta. H is going to 0, means this difference is very close to theta. And what is in that sense? Means what is the ratio? What is happening with the ratio? So see that how very closely we are looking output and input ratio, and what is happening with this one. So differentiability, so forget about this all. I will be back to with the, first I should to tell you the definition of the differentiability, which is now I am discussing here. Okay, but from the left, because I just uses the from left. Okay, but what is happening here? Differences, okay, and output differences upon input differences, and that differences I am making very close, very close to that differences, as that is meaning of H is goes to 0. It is from the left.
Sir, in this case, since it is just 0, we can also take it from the right hand side now, sir.
So now that's why this is called left. Now see that the difference, if you are taking this side, is also, so let's say this is theta plus H prime, I am saying with the different number. Okay, or even if you say again the same, we will use here. So here is HS is becoming, so let's with the different place here, let me make a different here. I'm writing for the right hand limit case. Right hand limit case, I should to first tell you that with this one I just move on. If you forget for the time being, I will back to this one. First see the what is happening here. So the same meaning is there, but the difference in this is, suppose here is theta, this is f of theta, and this is theta. Here a small increment I took, which I am saying H plus theta. Okay, and this is going to be here output, which is f of theta plus H. So take this difference, it is a kind of this one, and take this difference and divide that. So this difference is f of theta plus H minus f of theta, and divide f of theta plus H minus theta, which is nothing but H. So this is finally H is there. Okay, I am taking this ratio, and what I am saying here is H is something, it could be 1, 2, 3, whatever, but what will happen when this difference, this whatever the small increment in theta I am doing, that is very small. It is so this notation actually, please observe this notation. This notation is mean to say you are doing increment here very small, and you are taking ratio, and what is happening with the ratio. This is the definition of differentiability. Differentiability nothing but the output difference upon input differentiation, means ratio of output and input. And what is the ratio of after incrementing, what is the ratio of after incrementing I am taking the ratio, and very small increment I am doing, which is denoting like this. Okay, just a minute. So first thing, without going to be this forget about this one, spending on, I just spent time here, but I will back to this one. And we needed the notation thing, otherwise, to remove your fear. Otherwise, is this clear what is happening with the differentiability? What is happening? What is the differentiability? A small increment in output and a small what is happening after incrementing input and taking the ratio. And that increment is very, very close, very small, that is denoted as h goes to 0. Is this clear? No, yes, no.
Yes, sir. Sir, but when h tends to 0 minus, then there's a difficult thing. Like
Actually, minus
there,
minus positive, na f theta. Then
not
the
minus minus positive. When h tends to 0
So
minus.
here, forget about this one. We'll back to again. I will repeat it again. Okay. I will first write the definition. Okay. Forget about this one.
Okay. Okay. Sir.
So for the time being, just see on the definition of the differentiability. I will back to this one. So this is the definition, means a small increment, okay, in the output, and whatever the increment you are taking input, that is happening with the output, and taking the ratio, this one. That is, what is that when this increment is very, very small, that exists or not, the problem is of the existence. If it is exist, then that you will say function is differentiable. And if it is not, then you will say the function is not differentiable. And this limit is depend on the left and right. Okay, if left limit is here, this one. So we don't want also, actually, I just tell you with the notation, otherwise this is correct. Okay, these all are actually correct. So here is, this limit is nothing but so let me write again. So that the definition of limit is limit h goes to 0. So this is include both positive and negative. Okay, that's the meaning here. And this increment, this f of theta plus h minus f of theta. So this include both increment. It could be from increment or decrement. Okay, and upon h. So this is the existence. If this limit exists, then function is differentiable. So, but we have done with the left and right limit. I am just making here differences, that what is the left limit of this one is denoted as limit h goes to 0 negative. This is the meaning of left limit, f of theta plus h minus f of theta upon h. So this is the case of decrement. And here is right limit is denoted as h goes to 0 positive, f of theta plus h minus, this is case of our increment on h. Okay. So sometime what is the problem? No, why I were telling this one? Sometime it will be look like this. Okay, I'm just making h goes to 0 positive also. Okay, the same thing is here, 0 positive, but I am changing inner part. Okay, where is the plus? I am making with the minus. But these two are same thing, right? Because now you are approaching to 0 from positive. These two are same. That's why I said use to y. Now it will be clear to you. If you assume y is equal to minus h, okay, so this will become limit y goes to 0. This will become this part. This will become y goes to 0 positive limit, sorry, f of, okay, f of theta minus y minus f of theta on minus y. Where is y? So this is, if you assume here y is equal to minus h, that means h is equal to minus y. And where is h? Just put here everywhere minus. Sorry, everywhere minus y. Wherever the h is there, everywhere is minus. So this is in the y case. So if just change that variable, that y, h or anything, that's why you will get, if you change with the again the different h prime or whatever. I'm just writing. I nothing more. Everything I just change with the sign. Otherwise, this is the only one. Left limit. And this is called also left derivative. Okay, this is called right derivative. I hope all of you all of you have confusion on this. Right have don't have any issue because everything is positive, there is no. But left have issue, not this is not issue, it is just a notation format. I'm just denoting because so that denoting like this or this representing like this, the reason is it is actually in the saying decrement now saying, right? It is now decrement is saying. Here is unable to see the decrement, but now here is saying showing you a decrement now. That's why in this notation I'm writing. Otherwise these all three are same. And how I get this part? I got this part using this one. Using this one, I got this part. Is this clear?
Yes, sir. So, but so like, even if limit h tends to 0 only, like when h tends to 0, then finding the limit is compatibly, I think it is easy. But
this one.
Yeah, this like 0 minus it is written. If it is only 0, then also f of theta minus h it will become, and minus.
So here is if it is a 0, no. So here is two things always. Then you have to keep in your mind that okay, I am doing with the positive and negative both. Here it is. You have to keep in your mind that you are dealing with the positive and negative both. But then when you are dealing that, fine. But you have to deal with the separately also. So what is the problem? No, when you are solving sometime directly without assuming on positive or negative, just find the limit and it is actually say exist. But sometime problem with the left and right, and where it these all this is on the with the mod function.
Okay.
Mod
so like we have to find both the LHB and RHB. We have to find both of them. Then only we can say that this is differentiable.
If both are same also, because both should be same, because this is the left limit, no? Left limit is actually in this fashion, I am saying left derivative. This is right derivative.
Yeah, yes.
And if these two are same, then you will say limit exists and finally derivative, differentiable.
Okay. Okay, sir. Got it.
So this left and right actually arised from this mod, because mod function is only play with, sign.
Yes, sir. Mod function is something different.
Mod is just play with the sign only. See, the same thing is there, only the minus is there when it is negative. That's why this, and also this is a actually mod is actually saying the sharp corner. Now here is a problem, whatever I picture in the pictorial form I showed you. So now if you are able to, if I will write here the definition of limit. Okay, h goes to 0, f of theta plus h minus f of theta on h. So see, at this place function is not continuous. Okay, if not continuous, then if you think about the increment and decrement, okay, with the left and right, what will happen? Will both are same or different? In that case, if you think just in your mind, okay, in your mind, just think that on the picture here, if you are taking increment and decrement both separately and also taking the ratio, that ratio is going to be the same in increment and decrement case.
No, sir.
It will never be the same. Even if I will remove the limit, also from here itself, it will tell you that. If you are taking the increment and decrement, that ratio is going to be same from here itself, without taking the limit itself.
No, it will not same.
So in that case, if you take the limit, also not going to be the same. Just if you are substituting limit here, increment, decrement, very small. This is the meaning of increment and decrement very small. This limit means. So in that case, they are not same. So that means this is right, left derivative. This is right derivative. Both are not same. Okay, that means not differentiable. Also see it here. Okay, here is that. Actually, here is also not going to be the same. Okay, see that here is b plus h somewhere, and corresponding this is the f of b plus h. Here is suppose b minus h somewhere here. This is the decrement, and here is suppose this one f of b minus h. Now this side is f of b plus h minus f of b upon h. This side is f of b minus h. That is the difference upon ratio. Now what is happening here? If you take the increment and decrement, no, this side is, if you take the ratio, if you take ratio here, this increment and upon this, what is the increment happen? And if you take this increment and if you take the root, it is actually, you will not see. Okay, I will show you in the with the, so these cases happen with the sign only. No, these cases will happen only the sign, the, you know, why the reason is sign. So are you getting what I'm saying? The sign thing, sign means negative or positive. Increment and decrement. So increment, so value is going to be same. Like what is the, suppose this value you got -3, sorry, you got 3. Okay, this ratio you got 3 after taking the limit, or even without that, if you have a small thing, very small increment you did and you got 3. With the same small decrement, if you take the ratio, you will get -3. That's why it is a sharp corner is happening, because this is a decrement, this is an increment. Same ratio you will get, but with the different sign. I don't know all of you are getting or not.
I
It
think
is just
again
in
it
your
is not
mind. It is
differentiable
huh?
at this point. It is not
Sorry?
differentiable at this point.
At this point, function is so if you see the definition or if you see the lecture, where is the sharp corner, function is not generally differentiable. But
Yeah.
I am saying why the reason is here. Okay, suppose I will tell you that. Okay, I with the example it will be very much clear. So I'm taking a function mod x. Okay, I'm taking mod x function. Okay, so which is defined like this. Okay, at 0 it is not clear. No, I am just making a small change, and at -1 I am saying. So at -1, can you tell me how it is defined? How it will define? Now I'm not doing any differentiability continuity. I'm just asking mod function, and how the mod function, this mod minus, sorry, in mod x -1 is there. So how, if you in the stepwise, if you want to write, how you will write here? What is going to be that? At 0 we will concern, or at, sorry, at 1?
Sir, at 1.
At 1 we will see, because at less than, at 0 it will be, if you try
Minus
to, it will be -1, correct? So not -1, it will be 1.
+1, yes sir.
So problem here at 1 only, and the reason is it is going to be x -1 when x is greater than 1, and it is going to be the same -1, exactly the same in place of x. If it is like this, no, it is going to be x and -x. Just change with the x with the -1. See that the same thing is happening. It is 1 here. Okay, this is the function you have. Now I am just finding increment and decrement case. Okay, what is happening here? Now let's talk about here the differentiability in the algebraic form. So here is, I am taking increment which is a small increment at 1. So problem at 1 is only. Okay, here is the problem again at the step point which is 1. So problem at 1. So I am doing a small increment in h, and a small decrement, sorry, in a small decrement at 1 and a small increment at 1. So corresponding outputs are 1 plus h increment, and this is. And what is this one? What is going to be this one? 1 plus h. Please see the graph. Sorry, please see this function, how the function is defined. What is going to be? Either this one or this one. How the function, what is going to be 1 plus h?
Upper one. X minus 1.
Okay, 1. Here is, if I will write it. Sorry, here is 1. X, so this is going to be 1 plus h minus 1, right?
Sir.
Sorry. What is going to be that?
This is the continuous, no?
This is continuous.
Yes.
So what is the output? Can you tell me what is the output?
H, sir.
Always 1 plus 1.
It is
1
going to
plus
be
h
h, right?
minus 1.
This is 1 plus h minus 1, which is h. What is this one?
1
Positive, sir.
H plus
Negative.
minus h plus 2.
Sorry, 1 minus h is there. Sorry, minus 1, which is also h.
This is h. Yes, sir.
Yes.
So both we are getting the same h's there. Okay, fine.
Sir, but when x is less than 1, we have to take the, when we are taking that function, then it will be 1. Okay.
So let's see that what is going to be the next. I don't know. Also, with this, we are proceeding with the, I don't know what will happen. Okay. Okay. So now I am taking the differences. What is the one that increment case? Upon what is the increment? How much I took increment? H. Okay. Now this is the increment case. Okay. Okay. This is the increment case and decrement case. Okay. So f of 1 plus h. Sorry, decrement case is this one, f of 1 minus h minus f of 1 upon h. So now the decrement you will take, no, so h is going to be, so I have to take like this, no, 1 plus h minus h, sorry, 1. What is here? The same decrement thing, 1 minus h minus 1, right?
Yes.
That is the decrement. That is the increment here, that is decrement here. So this is going to be our h, and this is going to be our minus h. Okay. Now if you apply limit, okay, so here is the decrement. Okay. Now I am taking limit, h goes to 0. So here is our, what we got this one?
H.
No, function value at 1 is, so I forgot to write what is the function value at 1?
0.
It's 0.
Okay.
Yes.
So this is, we have 1 plus h, no? So 1 plus h is h minus 0 upon h. And in the decrement case, what we have? Also h. Minus 0
H
upon
minus
minus
0.
So, but we are
Minus
taking the
h,
limit
yes.
here. Here is the limit also. So if you directly to apply limit, we will solve, now you are able to deal with that. So,
Sir,
here is,
I have a doubt, sir.
the
left side, limit, the increment side, numerator, f of 1 plus h will be h minus 1. As per the definition of the function.
Sorry.
As according to the definition of the function, when x is greater than or equal to 1, the function is x minus 1.
X minus 1, yes.
So when we are taking the increment side, f of h 1 plus h will be 1 plus h minus 1.
Yes.
Okay.
That is h here.
Okay.
And this h is actually, we are taking h is positive. You are looking that. Are all of you are looking or not? We are in the case of h. That's why you are decrementing meaning here. We are taking h is positive here always. In the limit case also. Okay, that's why this decrement is happening. So please note this. Okay, H is positive case, then you are able to decrement 1 minus that is small decrement. H is positive here. Then able to write in this decrement or not. Is this clear? This part. If it is not positive, then how it could be? So only the sign problem is many times only the sign. Here is playing with the sign only. Negative, positive, negative, positive. Okay. So actually H is positive here. So here is now solve. If you are dealing with the limit, no, first we will solve the expression. So this is going to be 1. So limit as H goes to 0, this is 1. And what is happening here? This is without applying. So limit, first solve the expression, we will get -1.
-1. Yes, sir.
So now apply the limit. This is going to be 1 and this is going to be -1.
-1.
So what I said here, see that all of you are looking at what I said here. I got the same ratio but different sign, right? This is the same ratio but different sign. The same thing happening also here. Where is that? I said no. This is, if you assume this is 3, so left side, right side is 3. The left side will be 3, but with the negative -3. So at sharp corner, generally, if this things is happening with the symmetricity, with this as mod case or very sharp corners there, it will generally with the same height or even the same ratio with the different sign. Sometime it could be different. Okay, but for the mod case, it is actually happening the same. See that that is why it is so. In the pictorial form, you can see increment is this side you are taking. If you are taking the ratio, you will get the same, right? Same ratio you will get, but different sign.
Yes, sir.
So that's why it is not differentiable. At the sharp corner, generally you will see. This case is a totally different thing. What will happen? This is also not differentiable. I just wrote for all are actually not differentiable. This is not continuous, so not differentiable. We'll discuss that. Okay, we'll discuss this part. We'll discuss. So let's back to this one. This is what is happening. See that? Okay. Oh. So this is what is happening. No, this part is actually when I'm writing this limit h goes to 0, f of 0 theta plus minus f of theta on h. So what is happening when you are evaluating this limit is going to be infinite. This limit is going to be infinite. So why it is so? Let me tell you first thing that actually now we are studied with let me connect with your week 2 thing. Slope. I will take not much time. Okay, 15 minutes. I will take more. Let's see if we are continuing with this thing. Let me finish that slope thing. No, so in the slope, if you remember that in the definition of slope, if you have this is x1, this is x2, f of this is what is that?
y2 minus y1 upon
Y2
y2 sorry
minus
this is y1 y2. So this point is what? X1 y1. This is x2 y2.
Y2.
So what is the slope? y2 minus y1 upon x2 minus x1, right?
Yes, sir.
So
Yes, sir.
this line is nothing but a function, right? What is the function? What is how you write y is equal to that line you are writing. You can think fx is equal to that expression. So this
Yes,
could be
sir.
represented like f of x2 minus f. So yeah, f of x2 minus f of x1 upon x2 minus x1. What is the slope here is happening? Ratio of the outputs upon inputs. And what we are talking from the long time, ratio, so many times ratio only. Where is that ratio? Many times I took the limit then. Everywhere is ratio. Everywhere if you see that ratio and then small increment. In the taking the same. So see what is here? This difference. Sorry, what is this difference upon this difference. Same thing here we did. Where is the picture? This difference upon this difference. And I substituted very small. H goes to 0 means very small increment. That means that what is the differences you are taking? Very small differences, and then ratio. That's all. So what is, can you tell me different meaning of the derivative? Means whatever you, this limit you are getting, this limit in the case of here. Where is that? This one. What is this? I just calling different name, which is called slope. But there you, in the week 2, you will show slope of a line, right? Slope of a line there. Here, you used to say slope of a line. What you will call here? What you will call here?
Slope of curve.
Slope of curve or slope of function at theta.
Yeah.
Right? Now can you tell me, if you remember that, what is the slope of this line, this vertical line?
Not defined.
Not defined. Infinite generally you will say, not defined, or you will say infinite. So what is happening here? Now we are done with, no, everything is same meaning now. Slope of this is, right? This is what is happening. So, so first thing I forgot to, so now the tangent comes here. So what is happening here? No, this limit is actually telling you the slope. So slope of, so again, let me add one more word, that if you are talking about the slope, so tangent is what? Tangent line. Tangent line. Now we'll see the tangent line thing. If you are talking about the slope of a function, slope of function, okay, slope of function. So what kind of slope it's give? Means I'm saying slope of a function. So what is the slope you are getting? In which sense I'm saying the slope?
The slope of a curve.
Slope of the tangent at that point.
But what you will use that? What is that whatever you are getting this theta, what is this limit you will use where? Where is that limit? This one. Slope of function. What is the, whatever you are getting this limit, where you will use that? It is this thick limit I am saying, slope of the function at theta. So what is this number we will use? This number is that whatever the limit is you will get, that is slope of function. So slope of function means slope of a line. It will be that number, that limit you will get, no, that is going to be also the slope of a line which touches the curve at that point. That is called tangent. So this limit is called the slope. That tangent is tangent line, no, which having slope. So what is the slope of that tangent line? This is the slope of function. Slope, okay, of function is the slope of
Tangent. Got it, sir.
tangent. Okay, now back to our this picture, this bigger picture. What is the tangent at C? I draw already this one. This is the in denoting dot wise, but actually the
Parallel to
tangent
y-axis, vertical line.
Vertical line. And there is tangent is this one.
Slope is not defined there.
And that's why the slope is not defined here. That is going to be infinite. So in that case also we'll say, you will see that function is not differentiable.
Right, sir.
So this is called, in the, if you are getting this kind of thing, no, so at that point you will say the function is not differentiable. Also will say the slope is not exist in that sense also. So in the slope form, in this form you will say the tangent exists, but the slope is what? Infinite. Because So see, so many curves are there. Sometimes some curve have that exactly vertical line tangent, which is kind of this one. So that is also a slope. But this slope have this vertical line which is happening a tangent is having the slope infinite. And in that case, if you are getting the tangent line exactly the vertical line, at that point you will say the function is not differentiable. But yeah, slope is exist. Slope is exactly the vertical line. So what is giving the slope? Slope is in that is what your infinite thing is, that is vertical line. So this is the case here. So here at this point the function is not also differentiable. And what is the example for this one? Think about the function fx is equal to this one. X is equal to 1 by 3. If you try to find the limit, let's find the derivative, or let's find the check the differentiability at 0. At 0. So what is going to be? Limit h goes to 0, 0 plus h minus f of 0 upon h. This is the derivative, no? Now I'm just quickly writing. So what is this? What is going to be this one? Limit h goes to 0. Can you tell me what is going to be this one? For this function? Anyone?
Parabola, sir.
No. Parabola, okay. I'm saying this expression. What is going to be this expression? My screen is visible, right?
X
What is going to be
plus
this one?
h whole 1 by 3.
And this is
To
now
the
next
power
is 0 upon h. So that is exactly this one. And if you evaluate this limit, what is going to be? Or you can write, this could be written as limit h goes to 0, h upon 1 by 3 minus 1. Right? H goes to 0. This is become h 1 upon h. This is 2 by 3. And this limit exists? No. Right? This is infinite. This limit is infinite. 1 upon this goes to 0. This below thing goes to 0 means 1 upon 0 thing is there. Is this clear?
Okay, sir. But so that way it means derivative at 0 is not there.
Not exist for this function. And if you see the graph of x cube, root cube of x, this is going to be like this. S shape is there.
Okay.
Like this. See, I made the same picture. That's why I made like this. Where is that? This one.
Okay.
And this part is, I'm just leaving that. You see that again the ratio thing and see the differences. You will get a jump. That ratio is not going to be the same. Here is also a plus h, sorry, f of c plus h minus f of c upon h. If you see the ratio, it is not going to be the same.
So I have a doubt, sir. So when we did this was cube root function, at 0, if the derivative is not existing, correct, sir?
Yes.
We have to check 0 minus and 0 plus also? No, not needed.
So here is not needed. If you want to check, it will behave the same way. If you want to check, you can check. Okay. If you want to check this one, no, 0 plus and 0. So let's check that. So that's why I said sometime it's we have exactly dealing on the limit. Sometime some issue is there with the mod kind of. So where is the issue with the sign? No, at that places we will talk about only the left and right limit. But sometime it will not there is no issue with that. It will continue with exactly 0. There is no with the sign. If you deal with here, okay. If you deal with here, it will not happen anything. If you deal with the positive one, okay, this is going to be h upon 3 upon this is going to be the same, okay. And if you deal with the right, sorry, this is the right, this is the left. If you deal, okay, this is right, sorry, left. So this is going to be what? So 1 upon this upon h. Okay, now see that it is from 0 it is approaching. So this is negative number, this is negative number, both will be negative, right?
Correct.
And that's why it will give still give 1, and this will already, because of plus, it will give, sorry, not 1, that is going to be infinite.
Cancel. This
And
is
this is infinite, both
okay.
will go to infinite.
Okay. So
And
when
both
there is
will
no
become negative.
mod, then we don't have to find right and left. Directly we can find.
Yes, where is the, if there is a somewhere mod, then there is a issue other with the left and right, otherwise everywhere is the same, dealing with the same.
So for differentiability only.
Only the differentiability.
Yeah.
So not only differentiability, even if you see the continuity also, but mod function is continuous but not differentiable. Mod function
Yes.
is continuous,
yeah,
not differentiable.
Okay, sir.
So a function is, if a function is differentiable, then it is continuous.
Okay, sir.
the vice versa is not.
No, this is one-sided. Not, this is not true. This is one example, mod.
Okay.
Mod x. Oh, sorry. Not differentiable, but continuous. But not continuous. Then yeah, if it is continuous, but it's still not differentiable. Yeah, this mod is there. This mod function. This is continuous, but not differentiable. So this occurs one more thing. This.
That like every differentiable function is continuous. But every
continuous function is not differentiable. May not be. May or may not be.
Okay.
But these things will tells you one more thing, that if function is not continuous, if you do the negation of this statement, if you do the negation of this statement, what is going to be? Not continuous implies not differentiable.
Yes. Yeah.
This is the negation. This is the negation sign in the logic. If you do the higher mathematics, so logic, if you see the logic, this is exactly the logic thing. Okay.
Okay, sir.
So slowly, while discussing, we went very deep.
Yes, sir. Yes, sir.
But I hope it will be clear with the why.
Sir, your explanations are very nice, and other inspector not this type of explanation, only for short format.
All are good instructors. You are the best.
Now Shubham sir is the best because of very explanation deeply.
So I used to know. So if you are knowing the mathematics, so at least you should to know the reason why this is happening. Why this is happening? Because mathematics is based on the reason, like one by one step it reaches.
Yes, sir.
Okay, sir. Can I go, sir?
Yes. So that's all for today's session.
Okay, sir.
Thank you, sir.
Thank you, sir.
Yeah. Thank you so much.
Thank you, sir.
Take a question.
So yeah, I didn't discuss the activity. Anyone have listed remain? I will quickly do that and then we'll close the session.
Yes, sir. Activity 7.2.
7.2. Okay, doubts are there. 7.2.
Question number 3.
So this is still, so this is this is just needed, this here is composition, not multiplication.
So is that a printing mistake or what?
This is a typo. Yeah, this is printing mistake. There should be composition, f of g.
So that multiplication thing, it only works with the constant that's like of the format CF.
Yes, if you do the multiplication, no, it is actually showing the multiplication, but here is answer is actually given for composition.
Yes, sir.
This expression is for multiplication, but answer is given for the composition. This is an error.
Okay.
Sir, I have a doubt.
Okay, what is your doubt?
In graded assignment 7, I think it is question number 6.
Okay, question number 6. This one.
Yes, sir, that one, sir.
Okay, so I'm just suggesting that if you take 4 as a common, then what will happen? If you take 4 common.
Okay, then it becomes 3 plus 5
3,
plus
5, 7, odd pattern, no? So this will be becoming an odd pattern. So what is happening in the last then? It is 3 plus 5 plus 7 plus, and there is a 4 in multiplication. So what is this sum? I think sir have given the sum. What is that sum? If you take the till infinity.
No, sir, I don't know.
So this sum is actually given for 1 plus also, 1 plus 3 plus 7. So what I am doing, if you are making like this, subtract -1. If this sum is from 3, it is started. So I made, we can make like this, right? So now this sum is, I also not remember it in, I think it is n square. Odd sum is n square. Yes. Even like for the whole sum is n plus 1 by 2, but odd sum is n square. Yes.
Okay.
It is in the lecture, sir, is given that odd sum is, I think, n square. So finally this will become what? N square, this will become what? N square minus 1 upon n square.
Okay.
Now it is asking for limit. So where it will go? It will go where?
It will go to 1. So 4 times 1.
4 times 1 become 4.
Okay. Okay, sir. Thank you so much.
Okay. This I have some doubt. This I see left.
Yes, sir, I have a doubt in activity 7.1 last question in one option.
7.1.
Yes, sir.
Okay, last 7 point last question. This one.
Yes, sir. I have a doubt in fourth option.
Fourth option is F is injective of is of the domain F is this one. Okay, if the domain is this one, removing to be integer. From the integer, you are just removing 0. So is this injective at n?
Sir, the correct answer is BD.
So is this injective at 1? Sorry, at n for the n, if you are assuming to be domain as n?
Yes, sir.
How so? How it is so?
So it's 1, but in integer we are including negative also.
Okay, I'm just writing here. This is fx is x square plus 1 by x. Sorry, x plus 1 by x, which is, you can convert this like this, x square plus 1 upon x. So what is the answer? This is going to be injective also for integers. What is the answer? You are saying only B is true. No, for this one also it is going to be. Why it is so? Can you tell me? So why injective for natural number? The same answer will for integer also. Can you tell me why it is so injective for natural number? You're not getting, so let's do with the basic definition. No, as if you remember that, what is the basic definition of injective? If you take x1 and x2 from the from the domain such that f of x1 is equal to f of x2, this should implies x1 is equal to x2, right? This is the definition of 1
Yes, sir.
So let's solve that, and will that be, if we solve this one, we'll reach to here. Let's do that. So here if you do, so here is x1 plus 1 by x1 equal to x2 plus 1 by x2. This could be written as x1 square plus 1 upon x1 is equal to x2 square plus 1 upon x2, right?
Yes.
If you do multiplication, okay, I don't know I will reach to be correct or not. And this one set to one side, then this side, anyone. So this is x1 square plus x2 minus x1 x2 square. And also this both all send one side, okay, this side, this one also, this one also. So 1 plus x2 minus x1, this side is 0. Here is not plus, here is, if you take x1 x2 both common, then what will remain from here?
X1 minus x2.
X1 minus x2. And if you take here from minus 1 common, this you will get, right?
Yes, sir.
Now if you take finally x1 x2 from these two terms as a common, then you will get x1 x2 minus 1 is equal to 0, correct? Right?
Yes, sir.
So either this one 0 or this one 0. If this one 0, x1 x2 0, then we are done. X1 is equal to x2, right? Then we are done, correct? Because then we reaches to f of x1, this is equal to x1. It is 1 1, as the definition is satisfied, correct?
Yes, sir.
But if this is not 1 1, sorry, if this one is equal to 0, then we are trouble. If this not equal to 0, that means this is 0, and is this 0? We have to analyze that. It will be 0 ever. Can you tell me? We are playing on set on here. We are playing on here. Your x1 and x2 belongs to this set. It will be ever you will get, that means x1 x2 is equal to 1. You will take two number and you will get 1.
No, sir.
It will be never. That means your x1 is equal to 1 upon x2. And what is in that case? For all it is true. So only for 1 it will be true, but for except 2, what is going to be? Except 1 is, will that be ever true? X1 equal to 1 upon x2 on integers. And integer doesn't contain no rational. This is a rational also. So except 1, this will not true. And except 1 means x1 and x2 are both 1. And then it is happening with the same case. Correct? and except 1, this will never happen. That means this will always happen. And if this will happen, that means our function is 1, 1. No? Yes, no, Disha? Are you there?
Yes, sir.
So by this way, you can think. Is this definition is clear or not? This definition, you know, or you know this definition?
Yes, sir.
If you know, then proceed by this, and we reaches to here, and from here try to analyze with the domain. This is actually the process to proving also. So this is proving the function is 1, 1. How you'll prove the function is 1, 1? You will use this one.
So one more question, mock 4.
So first of all, is this clear? Disha?
So after x1 into x2, x1 into x2 is equal to 0 and go.
So here, till here.
Yes, sir.
So I am why it is 0? So this is a product of these two, no? This is a product of these two. So either this could be 0 or this could be 0. If you're assuming this is 0, then we are done. This is 0 and this is not 0. Okay. And if this is 0 and this is not 0, okay, not 0, then we are done. Our work is done. But if this is 0 and this is not 0, so what is happening in that case? In that case, if I'm assuming that this is not 0, that means this is 0 and this is not 0, means I'm assuming this is 0. This is a 0 means I will get this one, x1 minus x2 is equal to 0, and this means that x1 and x2 is equal to 1, and this means that x1 is equal to 1 upon x2. And this will happen in the domain of where? We are discussing on this domain, z, on integers. And this will, integers will not contain, right? Integers will, this is a fraction, no? This is a fraction. Then how it will be there? Except 1.
So this is not injective, right?
No. So here is, this is injective, no? So in the case of this will not happen ever. So this is not equal to 0. Except 1, this will never 0. That means this one is 0. This is a logic. If not 0 this one, then this will always 0, because your product is actually getting 0. This multiplication. This will never 0. That means this is 0. And this is 0 means our work is done. We reaches to x1. x1 minus x2 is equal to 0. This means x1 is equal to 0. x1.
Yes, sir. Yes, sir.
Okay. Okay. Oh, okay.
So mock, one more question last.
Okay. What is that?
Question mock.
I will just quickly take that. Okay. Last mock 5, 6.
Yes, sir. Mock 4. Yeah.
Okay. Which problem?
Question number 3.
This one. A is solution. A is the number of solution. So how many solutions are there?
This is different question.
Sorry, not this one.
No, sir.
Which question? Which question then?
Yes, sir. This one. Question number 6.
Okay.
So here, how to find like domain of composite function, and basically that.
So okay. So domain of composition means, you know, if you are taking the domain of composition, of two function here, f of g, so we'll concern here is what? If you will take so suppose I'm taking this one, x minus 1, okay, and gx is 1, sorry, x, okay, I am taking F composition G. What is going to be that? Or even X square. What is going to be F composition G? X square minus 1, right?
Yes.
If this is X square minus 1, oh, sorry, this is 1 upon, sorry, this is 1 upon X minus 1. So what you will get? 1 upon X square minus 1, correct?
Yes, sir.
Okay, so what is the domain of this one? So from this one, you are getting 1 here, right? You will get 1. But the problem is here, if you, this is a composition, no? So composition means that output you will get, that will be used for input in for the function f.
Yes, sir.
So that means in that sense, you will not take 1.
Yeah.
Means 1. So you will not take 1 for this one. And so that's why here is what is going to be the domain finally for the composition.
Real number minus 1.
Real number minus 1 also 1 also, right? Here is a square.
Yeah.
At you will get 1 here for x is equal to minus 1 and 1 also, right? For this one, x square, you will get output 1 for plus and minus both.
Yes, sir. Yes, sir.
And you are composing that will not work for f at least, because that is in the output of this one, create problem for the output for f. So that means the domain is going to be what? Real number removing to minus 1 and 1. Okay. So similarly, you can think here also. Okay, I'm just leaving now for you to solve this one. Okay. Okay. Okay.
So
Try
but
now yourself.
in this, how root 10?
So root 10 is just, substituting. So domain of the composition is going to be what? So if you compose here f of g, so inside if you substitute here, so what you will get here? That means here is what is the composition?
Oh, yes, I got it. I got it.
Will come, right? 10 will come.
Yes, sir. Yes, sir. It will be like, it will be infinite. Yeah.
Okay.
Okay.
Try. Okay. I'm just stopping. I'm just in a hurry. Okay. Thank you so much. Now.
Thank you, sir.